Alright, this problem here has given us two angles. We can see here we have two different things measured in degrees, and we're given a side length. If I were to take a look at the triangle ABC, if I wanted to sketch out a triangle, now I will say that often this isn't necessary once you're comfortable with these types of problems, but if I call this A, B, C, and this little a, little b, and little c, they gave us the side length A, they gave us big C, and they gave us big A. This is what we mean by an angle side triangle. As we work our way around it, we say we have an angle followed by an angle followed by a side. Once we get past that, once we check off our conditions for the fact that we can actually use law of sines here, we'll really not need this statement anymore. But I like to point out these different types so that we can kind of assess when and what we're using. So here, I want to go through my conditions for just a moment. We know that we must have an angle given in order to use law of sines, and we said that there were two of them. We need a matching pair of a side and its opposite angle. Well, we have little a and we have big A. So that's a matching pair of side and angle. And we want at least one more piece of information, which of course we do have right here. So that's me running through my basic checklist from my previous video of when we can use law of sines. Once we get to that point, we can say, well, look, we want to solve the triangle. That means we want to find everything else. We want little b, and little c. It's important to note that it's usually going to be easier, in fact, it's probably always going to be easier, to go ahead and find matching pairs of information if you can. So here I see that they gave me big C, but they did not give me little c. And so what I like to do is I usually write down the first thing that I'm looking for, which is little c here. And then I pair that up with whatever goes on the other side of the fraction. So here we want sine of big C. And then I want to set up a fraction based on what I've been given. I have little a and big A, so that's going to be the fraction I want to work with for now. Now, with some basic algebra, some just old school, we have division here of sine of big C that we don't want in the problem. We're trying to solve for little c right now. I know that I can take this sine of big C and multiply it to the top of this side of the equation. This tells me that little c is going to equal little a times sine of big C all over sine of big A. And those are all things that I can access. I know that A is 9, big C is 76 degrees, and big A is 44 degrees. So what I'm going to do is give my usual reminder that you'll probably hear too much if you watch a lot of my videos. To check your mode if you're using any kind of calculator, make sure that your radians and degrees, that you've chosen degree mode, because we are using angles measured in degrees, not radians. And so now I just want to go ahead and plug in 9 sine of 76, and then I'm going to divide that by sine of 44 degrees. And here we have our measure. We have about 12.57. We weren't told how to round, so I usually default to 2 decimal places if I don't know for sure. I wrote that approximate symbol a little higher than intended, but that's okay. There's the measure of little c. Now you might look at this and go, well, Mr. Moffat, I don't know how to find little b or big B because I don't have the other one. And a lot of people will stumble on these, but they're overlooking a very basic fact. We have two angle measures. Wouldn't the measure of angle B just equal 180 minus the other two angles? That seems pretty intuitive to me. So here we're going to go in and say 180 minus 76 minus 44, and we find out that our last angle is 60 degrees. Don't forget that that is part of our answer here. We're looking for all three other pieces. Maybe over here I should put a little c again just to make sure we're kind of keeping up with everything. If I look over here, I know that I need to find little b, just like I needed to find little c earlier. To find little c, I did a times sine of big C over sine of big A. In the same way, little b is going to be a sine of big B over sine of big A. So compare these equations here and down here, so up here and down here. If you need to take a second to figure out how I set this up, hopefully that makes sense. We just took little c and big C and replaced them with little b and big B. We said with law of sines that you could use any pair of variables in this way. And now we can plug in our values. So little a was 9. Big B we just found to be 60 degrees. And then we know again that sine of A was 44 degrees. There we go. Real fast, we'll just plug that in, we'll find that value. I will point out that if you plug things in using your fraction bar, things can be a little bit smoother to work with. It's really up to you, depending on the technology that you have at hand. The only reason I like this is that, and again here we have about 11.22. I did the same thing again here with the approximate symbol. That's a little weird. Not sure why I'm doing that. But there we go, about 11.22. Notice though that if I had done this sort of form with my first equation, when I first found little c up here, I could have just hit second enter on this calculator, and then instead of worrying about retyping everything in, I could have just replaced the 60 here with that 76 from before. So I could have kind of saved myself a little bit of time. But in general, this right here, this whole process that we've gone through, is how you're going to approach literally every single law of sines problem that gives you two angles and a non-included side. You can always go in and find one of your side lengths first or one of your angles first. And then whichever thing you haven't done, just work it all the way through. So you'll have these same three kind of setups here every time.